Good morning. The plan for today is to do a couple of different things, and I'm going to split it into two different videos so that you can choose whether you need to watch video number one. So today I want to go over the formative with you that most of you took on I've lost track of the days, on Tuesday. Also to go over some of the problems on the clever assignment that you did on Wednesday. So that's going to be on this video. If you don't need to do either of those two things, you can stop this video and then go to video number two. And video number two is going to be our new learning for today. We're going to determine if a triangle is a right triangle, and we're going to find the distance between 2 points using the distance formula. The first three problems on the formative had to do with graphing, and most of you got those problems correct. I wanted to go over them real quickly for those who were struggling with it a little bit. So first of all, on this problem, ignore my signature over here. I accidentally inserted my signature and I can't figure out how to get rid of it. So on this problem, it's asking you just for the domain. So we're really just concerned right now with this section, with this part underneath the radical symbol, that part right there. So we know that that has to be a positive number because we can't take the square root of a negative number. So when we're looking at the domain, we're looking for x is greater than or equal to something. So in order for this to be 0, x is going to have to be 4. That's the smallest number it can be in order to make this positive. So in this case, the domain is x is greater than or equal to 4. On the next problem, it was asking me to select the proper graph for this. So I know that with this -1 out here, it's not underneath the radical symbol, it's out by itself, that's the value that shifts my graph up and down. So I would normally start at 0, 0, but it would be raised up 1, excuse me, it's -1, so it's going to be lowered 1, so it's not that one, it's not that one, it's not that one. So here is where it starts at -1. And so that's why this is the correct answer. On this next problem, most people got half of this problem wrong, but I went through and adjusted your scores because I never taught you any of them where we had a negative underneath the radical symbol. So basically this is just asking you to compare this function to the parent function. So I know that +6 raises the whole graph up 6 units. So that's the part that we all should be feeling good about. That's the translation 6 units up. This other part, if you think about what it means to have negative x underneath the square root symbol, this still has to be positive. So that basically means that all of my numbers have to be negative, all of my x's have to be negative, so that when I put the negative in front of them, the opposite of a negative number is going to be positive. So my domain here is going to be all of the numbers less than 0. So that actually reflects it. So when I'm thinking of my normal function being like this, if I want all of the numbers less than 0, it's actually going to make it this way. So it reflects it across that y-axis. You didn't have to get that problem correct, and I adjusted for it. This next problem was the only one on the formative that was rationalized in the denominator. So when I start off with a radical in the denominator, but it's only one of 2 terms, then I have to multiply both the numerator and the denominator by the conjugate. So I don't just multiply by the square root of 23, I multiply by the conjugate, which is the same terms, and the opposite sign. And if I'm going to multiply the denominator by that, I also have to multiply the numerator times that. So my numerator becomes 2 times 5 plus the square root of 23. So I'm going to distribute. And then that all is over 25 minus 23. So I actually made a mistake the first time I did this because when I see that square root of 23 times the square root of 23, I know that's 23, and sometimes that makes me think that 5 times 5 is 5. But remember, if the 5 isn't the square root, I am going to multiply those two numbers together. So my numerator is going to be 10 plus 2 times the square root of 23, and my denominator is going to be 2. And I can reduce 10 over 2, and I can reduce 2 over 2, so that becomes 5 plus the square root of 23. The next two problems were solving square root functions, and pretty much everyone got those right, so I'm going to skip number 5 and 6. On problem number 7, most of you did the problem correctly, but weren't able to interpret the results. So most of you squared both sides of this, then you factored it, and you found that x plus 4 times x minus 3 are the factors. So then I want to solve them. So this becomes x equals -4 and x equals 3. And I think that a lot of people saw, well, there's two answers, but I only get to choose one answer. So some of you just chose the -4 to begin with. And the correct answer is x equals 3. So the reason why -4 is not a correct answer is because it works when I solve it, but then when I check it, I notice that it becomes an extraneous root. So when I'm checking it, I'm actually going to erase this so I have a little bit more room in here. So I'm going to check with the -4. So I'm going to put -4 plus 12 equals to -4. And this becomes the square root of 16 equals -4. And if you remember, everything that we're doing with square root functions right now, we're only taking the positive root because we're looking at only one. Think about the graph. We're only looking at one part of the parabola, so we always take the positive root. So that means that this would be 4 equals -4, which we know is not true. That's why this root is called extraneous. And you don't really realize that until you do the check. The next problem was to find the volume of the pyramid, and you should have learned how to find the volume of a pyramid last year, but I didn't really expect you to remember the formula, so I gave it to you on the Google slide. But when I'm finding the volume of a pyramid, I know that my volume is going to be the rectangular prism that I'm starting with. So the volume of my rectangular prism is going to be the x plus 3 times 3, and then times the height of the pyramid, which is times 4. So this would be the rectangular prism, but because it's a pyramid, I multiply times 1/3. So you might not remember where that 1/3 comes from, but when I teach this in my Math 7-8 class, we actually do some experiments to see that, in fact, it would take 3 of these pyramids to fill up that rectangular prism. So once I have this written, I also recognize that I want it to equal 12. So I'm going to set it equal to 12, and I'm going to do some simplifying here. So 3 times 4 is 12. 12 times 1/3 is 4. So I'm going to simplify all of those numbers, and then I'm multiplying times the square root of x plus 3. I want to isolate this on one side of the equation, so I'm going to divide both sides by 4. And I get 3 equals the square root of x plus 3. Now I want to square everything, both sides, so I get 9 equals x plus 3. I'm going to subtract 3 from both sides, and I find that x equals 6. I think on this next one, people just got flustered by the fact that it sounds complicated. So when I'm looking at a sphere and I'm finding the surface area of it, it's giving me the formula, and it's asking me, first of all, it asked me to use a graphing calculator, so I told you on the Google slides to disregard that part of it, but it's asking me for where the radius exceeds 5 inches. So I'm actually going to start with, what if it equals 5 inches to begin with? So I'm going to look at this problem and fill in 5 for the radius, and I've got the square root of s, which is the surface area, divided by the square root of 4 pi, which is in the denominator. Notice that I split this into 2 parts so that I've got the square root of something over the square root of something. So now I'm going to solve just like I'm solving an equation. I want to get s by itself, so I'm going to start by multiplying both sides by this denominator. So I'm going to get 5 times 4 square root of 4 pi equals the square root of s. And now I'm going to square everything. So if I'm going to square everything, this becomes 25, this becomes 4 pi, and this becomes just s. So I find that s is 100 pi. So then I would fill in 3.14, and I would get s equal to 314. So I know that it's a little bit more than 314 because 3.14 actually has some numbers after it. So this would be 314 point something something something. And then I have to go back to the problem, and it says at which the radius exceeds 5 inches. So I really want it to be something a little bit more than this. So that's why I wouldn't round down to 314. I would round up 315 to compensate for that decimal piece of it. Many of you put 314. That's fine. I went back and looked at who missed that question, and would give you credit for that if you had 315. It would be inches squared. And finally, the last problem is about a swing on a rope on a swing on a rope. It gives me this equation, and then it gives me some numbers to fill in. So it asks me to find the length of the rope, so I'm going to be solving for L when it takes 3.5 seconds. So I'm going to fill that in for T. So I've got 3.5 equals 2 pi times the square root of L all over the square root of 32. So I could square everything now to get rid of those square root symbols, or I could simplify it a little bit first. I'm going to go ahead and simplify it a little bit first because I don't like this denominator, so I'm going to have 3.5 times the square root of 32 equals 2 pi times the square root of L, and then I'm going to square everything. So 3.5 times 3.5 is 12.25. Square root of 32 times the square root of 32 is just 32. And that's going to equal 4 pi squared times L. So again, I squared the 2, I squared to the pi, and I squared to the square root of L. Now I'm going to divide both sides by 4 pi squared. 4 pi squared. And then I'm just going to do my calculation. So 12.25 times 32 divided by 4 times pi squared. I'm surely using a calculator for that, and I get 9.94. So it's 9.94 feet. This problem about the snowballs is pretty tricky. So it starts by telling me some information about where my friend and I are in relation to my house. So I'm going to put it on a coordinate grid and say that the origin is my house that I just erased. So there's the house, and it's telling me that I'm 20 feet north and 15 feet east, so that's where I would be. And my friend is 25 feet east and 10 feet north, so that's where my friend would be. So I'm really looking for this distance right here between that point and that point. And in order to find that, you have to have a right angle. So I'm going to actually draw another triangle in here that forms a right triangle. And I don't have it exactly on here, but we're going to use some of our measurements to figure out these exact lengths. So if I was 20 feet north and my friend was 10 feet north, then I know that this distance is going to be 10 because it's the difference between those two. If I was 15 feet east and my friend was 25 feet east, I know that this measurement is also 10. So once I have that right triangle, then I can find out that missing measurement. So I'm going to go back to my Pythagorean theorem. At this point, I get a squared plus b squared equals c squared. A is 10, b is 10, and I don't know c yet. So I solved the Pythagorean theorem for c and got 14.1 feet. And I did that quickly because my video is out.